Hello, class. I wanted to go over the week 3 formative assessment. And so here it is up, and you can find this under assignments. You can also find it under modules. For the week 3 formative assessment, you have an activity. Okay, so you click on this, that it will bring you to this page. And also, if you let me go back. This is showing now. Okay, I'll move that to other screen. There we go. All right, so if we go back, you want to click on the assessment. This will give you the directions. So you want to download that. I've already downloaded, and so I want to go through it with you. And so here you have the instructions, and these are the same instructions for each of your labs. And so I wanted to um, let you know that you should have Microsoft Word on your computer. And if you do not, I'm going to show you how to get the free download that all students have to get this on your computer. Because I noticed that a lot of students are printing these out, taking pictures, and then submitting them, where you can simply type your answers in directly into Word, save it, and then submit the file, and it'll make it a lot easier for you. So what you're going to do is this first part tells you a little bit of background information about atomic structure. So make sure you read through that. And then you get to the part where you're actually evaluating. This first part, you don't need the simulation for, you just need to answer the questions. And so they're asking about protons, neutrons, and electrons. Remember that atomic number, which is the number that is above the element in the periodic table. It tells you the number of protons as well as the number of electrons. And so, looking at the periodic table, carbon has an atomic number of 6. And so, the protons and the electrons would be 6. One thing to note that for isotopes, the number of protons and electrons do not change. What changes is the number of neutrons. To find the neutrons, you're going to take the atomic mass, which is listed at the bottom for the periodic table for each element, and you want to round that to a whole number and then subtract the atomic number. So the mass number minus the atomic number, that gives you the number of neutrons. Okay. And then you'll answer those questions based on what you've calculated. Then if we scroll down to part three, you're going to use this simulation. And so we want to build an atom, and you want to add protons and neutrons to the nucleus just to see what's going on. Okay. And then you add a combination of protons, neutrons, and electrons. And so I want to show you the simulation. So we're going to go back here and then go to the simulation. So this is the first simulation we're working on. Okay, so let me take that out first. All right, so you can add protons and neutrons, and you see, oh, first of all, you want to make sure that that's clicked. So you want the element, neutral or ion, and stable. Okay, so this, you have a proton and a neutron, it shows that it's a positive ion. And then we can add electrons, and that makes it neutral. You have more electrons. So if you have more electrons than protons, it's a negative ion. And if you have the same number of protons and electrons, it is neutral. If you have more protons than you have electrons, then it's a positive ion, and it'll tell you that it's unstable. Okay. If we take away one of the protons, now we have stable. All right. So if we take away the neutron, it's unstable. Say we take an electron and we take a proton away. Now it's stable. Okay. And it's neutral. So as you can see, it'll tell you as you add more protons, it tells you what the element is, whether it's an ion, if it's unstable, we can add electrons. So play around with this, okay? So going back here, if we scroll down, you need to fill in this chart. And so it gives you the symbols, okay, for the first 10 elements. You need to write their names. Remember, spelling is important. Write their atomic number, their mass number. Remember, the mass number is a rounded number. It's a whole number. The number of protons, neutrons, and electrons, okay? And then answer the questions based on that. Then we want to talk about isotopes. So when we look at isotopes, okay, now we're looking at, and you can always do this, that'll reset it. The isotope one, we're looking at this one. So we want to reset this. And so now it talks about how you want to add 8 protons, 8 neutrons, and 8 electrons. And then you want to give you the symbol notation, the symbolic notation for this element. All right, so if we look at here, say for example, I did for protons, we did 4 electrons. All right, and then we want to add some neutrons here. And make sure you click the stable and stable. We want to make this stable. All right, but this is an ion, so we want to add. All right, so now we have boron, a neutral atom here. All right, when they're talking about the symbol, this is the symbol that they're talking about. So you have a B, which has a up here at the top. Now this represents the mass number. This 5 represents the atomic number. All right, and so this is a shorthand way of writing the symbol. It's a bit different from what you'll see in the periodic table. This 0 over here tells you it's charged. So say we added an electron, okay? You see how the charge changes to a -1? So that would be what they're talking about for here. What is the symbolic notation, okay? Is the isotope stable or unstable? And so you'll find that information here, okay? And so this is just to give you an example. It's not the one that's listed here, but that's what you will type in for, I mean, that's what you'll put for your protons, neutrons, and electrons, and then you'll fill out this information. All right. And so then it'll ask you to add a neutron, add another neutron, and different things so that you get to here. One thing I do want to note for this particular calculation, it says multiply the mass by the percent abundance. You do need to change this percent to a decimal before you multiply it by the mass. So 95%, if we divide it by 100, that would change that to a decimal. Once you've done that, then you multiply it by the 16. All right, well, if you have any questions on this particular lab, then let me know. Have a great day.